Welcome to another level 3 probability distributions video. This is our last video for the Poisson distribution. We know the Poisson distribution is often regarded or recognized by a rate. We have 4 conditions that must be met for in order us to use Poisson, and it's important you know these 4 conditions in case they discuss or talk or ask about them in the assessment. All right. So far we only had one parameter, lambda, but in the last video we showed you there are a few more parameters that can be derived from Poisson, and that is the variance and the standard deviation. The variance is also lambda, and the standard deviation is equal to the square root of lambda. All right, well in this video we're going to finish off with Poisson by talking about inverse Poisson distribution, which is where you get given a probability and you have to work backwards to figure out lambda. So here's the example. Let's go through it. There's a little bit of algebra involved. On a particular Pacific island, the probability there is at least one cyclone in a year is 0.75. 75% chance there is at least one cyclone in the year. We need to calculate the average number of cyclones that island has per year. All right, the probability that x is greater than or equal to 1, at least 1, is 0.75, 75%. A probability distribution table, and the 75% or 0.75 represents either one or more cyclones in the year. So we can use that information, we can subtract it off 1 and get 0.25, and that tells us the probability that there are no cyclones in the given year. The chance of no cyclones is 0.25 or 25%, and we're going to use that to figure out lambda. Now to do that, we need to come back and use the probability Poisson distribution formula, which we showed you in the second video. So if you're not familiar with it, go back and watch that video once more. So we have lambda, that's what we're trying to find. And we're going to substitute x is equal to 0, because that's the probability of 0. Right, let's take that up to the next line over here so we can carry on our working and show you what to do with it. The first thing to do is to do some substitution. So we know the probability of x is 0, which we know is 0.25, can be replaced and put in here as 0.25. We know that lambda to the power of x, but we're using x as 0, so lambda to the power of 0, any number to the power of 0 is 1. No matter what number, 5 to the power of 0 is 1. 100 to the power of 0 is 1. Any number to the power of 0 is 1. So this part here of the formula becomes 1. And 0 factorial also is 1. That's just the definition. Remember factorial? 4 factorial means 4 times 3 times 2 times 1 times... No, 4 times 3 times 2 times 1. But 0 factorial has been defined as the number 1. So we're going to replace 0 factorial with 1. Now, the 1's cancel out and we're left with 0.25 is equal to this number e to the power of negative lambda. Now, e is an interesting number. It's a bit like pi. It's an irrational number. How do we get rid of e? Well, we're going to introduce some year 12 algebra, and we're going to come back to some natural logs. And we're going to take the natural log of both sides. Now, the natural log is basically log of base e. Now, if we take the natural log of 0.25, I just type in my calculator ln, I push ln, and then I type in 0.25. That gives us negative 1.386, and I'm going to round that to negative 1.4. But when I take the natural log of the other side, the natural log and the e cancel out, and that just leaves us with negative lambda. Now all I need to do is divide both sides by negative 1 to get rid of the negatives, and I've figured out that lambda is 1.4. So I've solved my problem. Lambda is my expected value, my mean. The average number of cyclones that the island has each year is 1.4. Right, that's us. Thank you so much for watching.